Hello everyone, my name is Varsha. In this video, I'll be talking about introduction to connectives and truth tables related to DMS subject. Connectives are the logical operators that allows us to combine simple statements into more complex ones. Understanding truth tables is crucial for evaluating the logical relationships between these compound statements. Coming to first operation, that is conjunction, or either way it can be said as AND operator. Definition: the conjunction operator is a logical operator that returns true if and only if both of its operands are true. Truth table: the truth table for conjunction shows that the result is true if both input values are true and false otherwise. In the sense, if one of the values is true and the other value is false, it will end up as false. Boolean logic: in Boolean logic, the AND operation is a fundamental building block for more complex logical expressions and circuits. The next operation, which is OR operation, which is also called disjunction. The OR operator, represented by the logical OR operator, is a fundamental connective in Boolean logic. It evaluates to true when at least one of its operands is true. Truth table for disjunction shows that the output is true whenever either or both of the inputs are true, and false only when both inputs are false. Disjunctive statements use the OR operator to combine two or more propositions, creating a compound statement that is true when at least one of the individual statements is true. The last operation, negation, or the NOT operation. The negation of a statement is the logical opposite of that statement. It reverses the truth value, turning a true statement into a false one, and vice versa. The truth table for negation shows that if a statement is true, its negation is false, and if a statement is false, its negation is true. The logical symbol for negation is the approximation symbol or the word not. For example, if it is raining, then the negation of that statement will be it is not raining. Conditional or if then statements. Conditional if then statements. The conditional statement or if then statement is a fundamental logical operator that links two propositions. It states that if the first proposition is true, then the second proposition must also be true. Truth table for the conditional statement shows that it is only false when the first proposition is true and the second proposition is false. In all other cases, the conditional statement is true. Biconditional or if and only if statements. The biconditional connective represents a logical equivalence between two statements. It is true when both statements are true or both are false. The biconditional if and only if is a symmetric relationship, meaning the statements can be reversed without changing the truth value. The biconditional indicates that one statement is a necessary and sufficient condition for the other statement to be true. Coming to logical equivalence and the laws of logic. Logical equivalence. Two logical statements are logically equivalent if they have the same truth value for all possible combinations of truth values of their component parts. The laws of logic. The fundamental laws of logic include the commutative, associative, distributive, and identity laws, which describe the relationships between logical connectives like and, or, and not. Simplifying logical expressions. By applying the laws of logic, complex logical expressions can be simplified and rearranged to reveal their underlying structure and relationships. Let us see some of the laws of logic. Those are commutative, associative, and distributive laws. Commutative laws state that the order of the operands does not affect the result of conjunction. So if A and B is the condition, then it is also equal to B and A. And disjunction also, A or B is equals to B or A. Associative laws states that grouping of the operands does not affect the result of conjunction. In the first condition, A and B are grouped and it is equal to A and B and C are grouped in the second condition. It also works for disjunction operation. A or B or C is equals to A or B or C. Distributive laws. The distributive laws shows how conjunction and disjunction interact, allowing us to distribute one over the other. A and B or C is equals to A and B or A and C, and A or B and C is equals to A or B and A or C. Some of the logical implications and rules of inference. Logical implication, denoted by the symbol implies or tends to, represents the relationship where if one statement is true, then other statement must also be true. This forms the basis for logical reasoning and inference. Rules of inference, such as modus ponens and modus tollens, allows us to draw valid logical conclusion from premises. These rules are fundamental tools for deductive reasoning and problem solving. Logical arguments. Constructing and evaluating logical arguments is a crucial skill in fields of mathematics, computer science, and philosophy. Understanding the structure and validity of arguments is key to making sound logical conclusion. Coming to the summary, we can conclude that by learning all these operations, we can master logical foundations, apply logic in real world context, and develop our analytical thinking. By understanding the fundamental logical connectives and their truth tables, as well as the laws of logic and rules of inference, we have a solid foundation for more advanced reasoning and problem solving. Applying logic in real world context, the principles we have learned can be applied to a wide range of fields, from computer science and mathematics to philosophy and critical thinking. Recognizing logical patterns and implications will empower you to make more informed decisions. Mastering logical concepts promote clear and structured thinking. This skill is invaluable in academia, the workplace, and everyday life, helping you analyze problems, evaluate arguments, and reach well-reasoned conclusions. Thank you.